Good morning all of you. In the last class we have completed the filtration process. And today we will go for the next topic, that is disinfection of water. So the filtered water which is obtained from slow sand filter or rapid gravity filter normally contains some harmful disease producing bacteria. So these bacteria must be killed so as to make the water safe for drinking. Therefore, the chemicals that is used for killing these bacteria is known as disinfectant, and the process is known as disinfection or sterilization. This process is important because the contaminated water may lead to the spread of various diseases. So the presence of generally the presence of turbidity, color or mineral may not be dangerous, but the presence of even a single harmful organism will prove to be dangerous. The disinfection not only remove the existing bacteria from the water but also ensure their immediate removal in the distribution system. The contamination of water during its transit from treatment plant to the place of its consumption is required to be prevented by the residual quantity of the disinfectant used. Clear? So, the disinfectant which will be used should be harmless, unobjectionable to tongue, economical and easily measurable. And chlorine has found to be the best and most ideal disinfectant, and it is now used throughout the world. Besides chlorine, there are some other methods of disinfection. So now we will discuss about those methods. So these are the following methods of disinfection, such as boiling of water, treatment with excess lime, use of ozone, treatment with iodine and bromine, treatment with ultraviolet rays, treatment with potassium permanganate. So now we will discuss about this method. So first, boiling of water. The bacteria that is present in water can be destroyed by boiling it for a long time. This is an effective method, but it is not possible to boil a huge amount of public water supplies. And it will kill the existing germ, but it cannot take care of the future contamination. So this method is not used for disinfecting public supplies, but during waterborne epidemics, public is advised to drink boiled water in their houses. So next method is treatment with excess lime. As you know, lime is generally used at water purification plant for softening of water. Okay, but it has been found that if lime is used in excess quantity, so this can also kill bacteria. So the addition of 14 to 43 ppm of excess lime can remove bacterial load by about 93 to 100% from highly polluted bacteria. But this method is practical for complete removal of bacteria, but the excess lime is to be removed from the water before it is supplied to the public. Therefore, the treatment like recarbonation is required for removal of lime if this method is used for disinfection. Okay. And also it cannot protect the water from recontamination. Hence it is not used in these days. Third one is treatment with ozone. So ozone gas is a faintly blue gas of pungent odor and it is an excellent disinfectant. And this can be produced by passing high tension electric current through a stream of air in a closed chamber. So the ozone that produced is highly unstable and it will breaks into oxygen and nascent oxygen, and this nascent oxygen is a powerful oxidizing agent and it will remove the organic matter as well as bacteria from the water. And during the treatment, the ozone gas is manufactured and bubbled through water contained in a sterilizing chamber, and that chamber is having inlet and outlet for water as well as inlet for ozone. And after the treatment process, the ozonized water comes out through the outlet. So this method has different advantages such as ozone being unstable. Ozone is unstable, therefore nothing will remain in water by the time it will reach the distribution system. Second one is ozone remove color, taste and odor in addition to removing the bacteria from it. And the ozonized water becomes tasty and pleasant. Then it has certain disadvantages also. It is very costly and it needs electricity for its manufacturing, and as it is highly unstable, it does not ensure future contamination, a safety against future contamination, and it is required one apparatus called ozonizer for manufacturing of ozone. So this is all about the treatment with ozone. Next, the treatment with iodine and bromine. So the addition of iodine and bromine to water can help in killing the pathogenic bacteria, and the quantity of this disinfectant is limited to 8 ppm for a contact period of 5 minutes. These disinfectants are nowadays available in the form of pills and thus are therefore these are very handy. But this is not used for treating large scale public supplies, but it is suitable for treating small water supplies such as private plants and swimming pools, etc. Next treatment is with ultraviolet rays. So these ultraviolet rays are basically found in sunlight, and this can be produced by passing electric current through mercury enclosed in quartz bulbs. This method is highly effective in killing bacteria, and but it is very costly, and there may be possibilities of interruption due to failure of electricity. Hence, this method is unsuitable for treating large scale impurities, large scale public water supplies, but this can be used for treating small quantities of water such as in hospital and dispensaries for surgical uses, and also this can be used for your treating swimming pool water in developed countries. Next method is treatment with potassium permanganate. So potassium permanganate is a popular disinfectant and it is generally used for disinfecting well water supplies in villages which are generally contains lesser amount of bacteria. And also this treatment is suitable for producing it also help in oxidizing the taste producing organic matter. Therefore this can be added in small quantity such as 0.05 to 0.1 milligram per liter for already filtered and chlorinated water. And for treating well water supplies, small amount of potassium permanganate is dissolved in a bucket of water and is mixed with the well water thoroughly. Then the well should not be used for at least 48 hours after the addition of potassium permanganate. The normal dose of this disinfectant varies between 1 to 2 milligram per liter with a contact period of 4 to 6 hours. This potassium permanganate is cheap, but it cannot guarantee 100% removal of bacteria. So this is all about your different methods of disinfection. In the next class, we will discuss about chlorination. Thank you.